This one says that C is the midpoint of both of these diagonal lines here. So that means that it cuts each of those segments into two equal pieces. So we can mark that these two parts are congruent and these two parts are congruent. And then looking at the picture, I see it looks like a bow tie, which means we have vertical angles. So we can also mark those. So we have two sides and an angle. The only two of the options that we can use are HL or SAS. For this one, we don't have a right triangle, so that's not going to work. We have two sides, and it turns out that angle is right in between those two sides. So this is going to be SAS. Now in the given information, they didn't say anything was congruent, so we cannot mark anything off. So let's start with telling what in the world this C is the midpoint means. That's how we marked that the two sets of sides were congruent. So we're going to put BC is congruent to CD. And since it has the same reason, you can do this part in the same step. So AC is congruent to CE. And all that is because C is the midpoint. So it's the definition of midpoint. Okay, now we can mark off two of the S's. Then for step 3, I'm going to get to the angle. We can't call it angle C. There's too many angle C's in the picture. So we're going to put angle ACB is congruent to angle DCE because the vertical angles are congruent. Okay, the order here didn't matter. If you switched 2 and 3, if you did the angles before the sides, that would have been completely fine. So we just said the angles are congruent. You can mark off the A. We've marked off everything on our to-do list. So we can say the prove statement, triangle ABC is congruent to triangle EDC by SAS. And that is the end.